Yeah, so I hope everyone is there. Let me check again. Yeah, good evening, everyone. Good evening to all of you who have joined. Yeah, namaste everyone. Good evening, everyone. Can everyone hear me? Hello, can everyone hear me? I hope everyone can hear me. Can all of you hear me? Yes, very good. Okay, so let us wait for other people also to join. Okay, I think some familiar names are missing from the uh, attendees list. So let's wait for them. Okay, so Abel, hi Abel, Akshad, Amreel, and Gauri, Sejal, Udeepa, hi everyone, hi. So it's been almost a week, right? So it's last week we were studying the chapter, I guess. What was the chapter? The last one, pair of linear equations with two variables was the last chapter. So it's been around a week, and nice to see everyone back again. Okay. Yes. Is my voice audible? Like, am I fluttering? Like, is there any disturbance in my voice? Is it clear? Is my voice full clear? Is there any other issues that you guys are facing? Yes. Okay. It's clear. Okay. Okay, so let's start with a new chapter, okay? And what is the new chapter? Understanding quadrilaterals. So the third chapter in your textbook, that is Understanding Quadrilaterals. So very important chapter and an easy chapter also. Sometimes it is easy. For some people, this is quite difficult. Okay, so we will clear all the doubts and all the concepts also in this session. So let's start with what is the quadrilateral and what are the things that we have to study in this particular session. Okay, yes. So the first thing is, what is a concave and convex polygon? Okay, before going on to what is concave and convex, I want to ask everyone, what is a polygon? What is a polygon? If somebody is asking you a polygon meaning or a definition, how will you give a definition for a polygon? Can anyone put that in the chat? Can anybody put that in the chat? What is the definition you can give for a polynomial? A closed figure made up of line segments. And Gina Jude. Okay, very good. Is there anybody else who's having a definition? Please put that in the chat. And said that it is a closed figure made up of line segments. Okay, very good. And anybody else? Please put that in the chat. Please, please, please. And as I said in the last classes, don't drop your energy till 7 o'clock. Okay, make let the energy be the same. And okay, made up of 3 or more line segments. Anne has said that it is made up of 3 or more line segments. Akshar has said that it is same. Okay, Akshar. Is there anybody else who is having a definition? Please put that in the chat. Please, please, please put your a definition of a polygon in the chat box. Closed figures made up of line segment. Yes. So everyone is saying the same definition. So what is a polygon? A polygon is nothing but a closed figure. A closed figure which is made up of what? Which is made up of line segments. Which is made up of line segments. And the minimum number of line segments that is required, the minimum number of line segments that is required to form a closed figure or a polygon is what? It is 3. Because you know that you need at least 3 lines to make a what? Triangle, right? So a triangle is the least polygon that is possible. So that is 3-sided. It is a 2D figure. Yes. So Gauri has said that it is a 2D figure. Yes, it is a 2D figure. Why it is called as a 2D figure? Because you can draw this in a paper. Can you draw this in a paper? Yes, you can. Because you can draw this in a paper, this can be also called as a 2-dimensional figure or 2D. Okay, two-dimensional figure or a 2D figure. Okay, so this is the definition of a polygon. Now, a closed figure which is made up of line segments. So the three sides when you have a triangle. Now, when you have four sides, what will you call? You call such one as quadrilaterals. So you call them as what? The quadrilaterals. Okay. Now, our chapter is based on understanding quadrilaterals. So we will be focusing more on what? We will be focusing more on the polygons which are having how many sides? The polygons which are having four sides. Clear? Yes. Now, the first two things over here, what is a concave and what is a convex polygon? What is a concave and what is a convex polygon? So when you talk about concave and convex, it is very important to understand what exactly do they mean. Okay. In our textbook and in our syllabus, we don't have to study both. We only have to study one. I will tell you which one is that. Okay. First, before that, what is concave and what is convex? For example, can I draw this four-sided figure like this? Can I draw it like this? Yes, I can draw it like this. Now, can I draw it like this? Can I draw another four-sided figure like this? A, B, C, D? Yes. So this is also ABCD, this is also ABCD. Both are how many sides? Both are having four sides. Okay. Now, which one is concave and which one is convex and why? Which one is concave and which one is convex and why? Okay. So you always know what is this angle. What is a straight angle? It is always 180 degree. It is always 180 degree. So if I extend this one, till here it is how much? 180 degree. But there is something more here. So that means this angle over here, can you see this angle, everyone? Can you see this angle? Yes. So this angle over here, is it greater than 180 degree? Yes. So in a concave polygon, one angle, at least one angle will be greater than how much? Greater than 180 degree. Such polygons are called by the name concave polygons. Okay. Such polygons are called by the name concave polygon. So what is a concave polygon definition? It is a polygon with at least one angle greater than 180. One angle greater than how much? 180 degree. Clear, everyone? Please write it down along with my lecture. Okay, you can take this as a notes or something and you can write it down. And if there is any figure also, please draw that. Figures are very important in any geometry chapter. Okay, so even if you don't have any particular figure to be drawn and everything is given in the question paper also, please draw a rough figure and keep it. Okay, when you draw a rough figure, you will always get the answer easily. So this is my tip. And when you talk about convex polygon, there is no angle. All the angles are what? All angles are less than 180 degree. All angles are less than how much? 180 degrees. So this is the basic difference between a convex and a concave polygon. Clear, everyone? Understood? All of you? Please show your energies in the chat box. Please, if everyone understood, please put a thumbs up in the chat box, please, everyone. And those who are watching in YouTube, you can put all your doubts and all your reactions in the chat box itself. Okay, and I will be reacting to all this and I will be replying to all your comments also. So please put your valuable comments and valuable feedbacks and everything, whatever may be doubts or questions or and something regarding maybe not only polygon. If you are having any doubt in other chapter also, please put it here. Okay, and everything is based on time. So if we are having enough time to solve all these things, we will be solving. I will be definitely solving all these questions to you. And those of your friends who have not joined it, please put a message to them in between to join the class. Okay, if your friends have not joined, if you know some of the friends that who have attended the previous classes, and if they have not joined, please put a message to them and ask to join very fast. Okay, yes. So let's move on to the next one. So understood convex and concave polygon, everyone? Is there any doubt? Anybody is having any doubt in this topic, concave and convex polygon? So examples of convex polygon, if I am asking you to draw examples of convex polygon, you can draw like this. This is one convex polygon. Yes, this is a convex polygon because this angle is more than how much? 180 degree. This one over here, is this also convex? Yes, this is also, sorry, this is also concave. This is also concave. This is also concave. Now this one convex. Now if I draw 5 sides, yes, this is also convex because all the angles over here are less than 180 degree. Okay, so understand the basic difference between concave and convex. concave will have more than 180 degree one angle. Convex will have all angles less than 180 degree. Yes, clear? Okay, so now let's move on to the next topic. What is that? It is regular polygon and irregular polygon. What is a regular and what is an irregular polygon? Okay, how will you define a regular polygon and how will you define an irregular polygon? So as polygon, we know the definition. What is a polygon definition? It is made up of, it is a closed figure made up of line segments. It is a closed figure made up of line segments. So if somebody is asking you, what is a regular polygon? What is a regular polygon? So convex polygon has its diagonal as its in its interior. Yeah, Bhavya. So I'll just go back. So in a convex polygon, you can draw all the diagonals here itself. But in a concave polygon, you draw this diagonal, it will be outside. Okay, very good, Bhavya. Bhavya has said that in the chat. I am just putting that again here. In a concave polygon, you can have a diagonal outside also. But in convex polygon, all the diagonals will be inside. Here, look at this one. Here is this diagonal outside. Yes, this diagonal is outside here. So that means in a concave polygon, what is possible? An outside diagonal is possible. But in a convex polygon, all diagonals are inside. Clear? Yes. So thank you, Bhavya. Thank you for putting that message. Okay. And yeah, talking about regular and irregular polygon. We were talking about this regular and irregular polygon. Akshat has put a message. A regular polygon has equal all sides and are same length. On the other hand, irregular polygon has sides of varying sizes and varying angles. Yes, very good, Akshat. Very good. Abel also has put a message. Yes. So when we talk about polygon, which is made up of line segments, if I draw a triangle, there are different types of triangles you might have studied in your previous classes. Isosceles triangle, equilateral triangle, scalene triangle, obtuse triangle, right angle triangle, acute angle triangle. So these are different kind or type of triangles we have studied, right? So in that, if I'm taking an equilateral triangle, what triangle? Equilateral triangle. So if this is an equilateral triangle, what is the speciality? All the three sides will be equal. AB will be equal to BC will be equal to what? AC. So this is in the case of an equilateral triangle. Yes. Now, not only sides are equal, what else also will be equal? Can we say this angle is equal to this angle is equal to this angle? Yes. All the angles will be 60 degree each. Yes. So if AB equal to BC is equal to AC and also angle A equal to angle B equal to angle C, then can we call this as a regular polygon? Yes. So what is the definition of a regular polygon? A regular polygon is nothing but all sides are equal. All sides are equal and all angles are also equal. Understood? So all sides equal and all angles are equal. Please write down this about regular polygon. All sides are equal and all angles will also become equal. Clear? So this is about equilateral triangle. Now, if I talk about quadrilateral, what is the quadrilateral having all four sides equal? Square. So if I take a square ABCD, okay, ABCD, all sides are equal? Yes. So all sides are equal. AB equal to BC is equal to CD equal to AD. Now, not only all sides are equal, are all angles also equal? Yes. What about all angles? Angle A equal to angle B equal to angle C equal to angle D, and that will also all be how much? 90 degree. This is in case of a square. Okay. So all angles are equal. All sides are also equal. So is square a regular polygon? Is square a regular polygon? Yes. So square is a regular polygon. Understood? So square is definitely a regular polygon which is having all four sides equal and all four angles also equal. Okay. Now, instead of square, if I talk about a rectangle, when I talk about a rectangle, can you see that all angles are equal? Yes. Angle A equal to angle B equal to angle C equal to angle D. Yes. All angles are equal. But are all sides equal? No. Only opposite sides are equal. AB is not equal to all sides. AB is equal to CD. AB is equal to CD and BC is equal to AD. So not all sides are equal, but only opposite sides are equal. And you had put a message in the chat is opposite angles are equal, but I think you meant that it is opposite sides are equal, right? Yes. So here in a rectangle, only opposite sides are equal. So is this regular? No, this is not regular. This is what? Irregular. This is what? Irregular. Understood? Yes. So what is an irregular polygon? How will you define an irregular polygon? Irregular polygon is nothing but a polygon having sides and angles which are not equal. So when sides or angles are not equal, when sides or angles are not equal, then we can call them as what? Irregular polygons. We can call them as irregular polygons. Understood? Yes. So in triangles, what is an irregular polygon in terms of triangle? If I talk about a scalene triangle, ABC. So here AB, BC and AC are not equal. AB is not equal to BC is not equal to AC. All the three sides are not equal. So if all the three sides are not equal, then we can definitely call them as what? An irregular polygon. Understood? Can you write down this, everyone? Please, please, please. Those of you having any doubts or anything, please ask in the chat. Please put that in the chat here itself. Okay, this is an easy topic, right? This is kind of an easy topic, which is very which is not that very hard to understand. One class or one time, when you hear one time itself, you will remember this. You will never forget regular and irregular. Okay, so don't forget this one, regular and irregular polygon. Yes. So as I said earlier, those of you who have not joined, your friends who have not joined, please ask them also to join and let the count increase. Okay. Yes. So can we move on to the next topic? Yes. Sum of measures of exterior angles of a polygon, which is a very important concept. Important concept. Okay. Sum of measures of an exterior angles of a polygon. So if I draw a triangle, this angle, and this angle, are all these angles interior or exterior? Can you see these angles? These angles are what? Are they interior or exterior? Angle A, angle B, angle C. Are they interior? Yes. So these are interior angles. These are what angles? Interior angles. Now, if I extend this line, okay, I'm extending this line. And I'm also extending this line. So I have extended this line, and also I'm extending this line. So what did I do? I extended all the three sides. Okay. So what I have extended all the three sides over here. Okay. Yes. So now when I have extended these sides and I'm marking P, this one is Q and this one is R. Okay. Now also, if I just draw this one and draw this angle, what is the name that you can give for these angles? What is a special name that you can give for this angle? Yes. So they are definitely exterior angles. I'm not going to give them the full names. Angle 1, angle 2, angle 3. So is angle 1, angle 2, angle 3 exterior angles? Yes. So these are exterior angles. These are what angles? Exterior angles. Exterior angles are those angles which are outside the triangle. Okay, which are outside the triangle. Not only triangle, quadrilateral also will have exterior angles. Now, is this an exterior angle? Yes, this is also an exterior angle. This is the same as what? Angle 1. This is also an exterior angle. But is this an exterior angle? If I draw this, look at this one. Everyone look at this one. Is this an exterior angle? When I draw this one, is this an exterior angle? No, that is not an exterior angle. Okay, so everyone do remember this one. This one is not exterior angle. Okay, so which are the exterior angles here? Angle 1, angle 2, angle 3. And these exterior angles have a speciality. What is the speciality of the exterior angles? We know that angle 1 plus angle 2 plus angle 3 will always be equal to how much? 360 degree. So the exterior angles in a triangle will always be how much? 360 degree. The sum of exterior angles of a triangle will be 360 degree. How did we get this? That is very important, right? So how did we get this property? So look here, when I take this one, what is angle A plus angle 2? What is the angle A plus angle 2? Look here, what is the sum of angle A and angle 2? Is it 180 degree? Look here, angle A plus angle 2, is it 180 degree? Yes. Now look at angle B and angle 3. What is the sum of angle B plus angle 3? Is that also 180 degree? Yes. What is the sum of angle C and angle 1? Angle C plus angle 1, is that also 180 degree? Yes. So now if I add all these three, I'll be getting angle A plus angle B plus angle C plus what is the remaining? Angle 1 plus angle 2 plus angle 3 is equal to 180 plus 180 plus 180. What is 180 plus 180 plus 180? It will be 540. What is the angle? It will be 540 degree. Okay. Now, what is angle 1 plus angle 2 plus angle 3? Exterior angle. They are exterior angle. What is angle A plus angle B plus angle C? Angle A plus angle B plus angle C is interior angle. What is the sum of interior angle? Do you know that it is 180? Yes, it is 180. So can I put this as 180 degree plus angle 1 plus angle 2 plus angle 3 equal to 540? Yes. So from this, what is angle 1 plus angle 2 plus angle 3? This 180 will go to the right side. It will become 540 minus 180. What is 540 minus 180? That will be definitely equal to 360 degree. Clear? So this is how we get the exterior angle sum of a triangle as how much? 360 degree. Is that clear to everyone? Did everyone understand this property? How did we get this 360 degree? Don't just simply study this 360. 360 degree, everyone knows. In school, if there are 100 students in your class, every 100 student will know that it is 360 degree. But how did we get that 360 degree? By using this method. This method is also very important. Okay, please write down this method. Please draw this figure and mark the angles. Okay, don't forget to mark the angles, and after marking, don't forget to put a name of the angle also. So these things are very important. Marking angle and naming angle, both are very, very, very important here. Okay, can you guys do that? Can you all do this question? Sorry, not do this question. Can you all write it down, please? Fast, make it fast, make it fast. If any doubts you guys are having, please put that in the chat box. And those of you who have finished writing, please tell me in the chat that you have finished. Okay, Abraham John. Yeah, Abraham, tell me what happened, Abraham. Any doubts from your side? I saw you. Yeah, your hand is raised, I think, in the chat. Is there any doubt, Abraham? Any doubts you have? Please tell me here. Any doubts you have? Yeah, I had a confusion here. What happened? How did it became 540? You see this 180 plus 180 plus 180. What is 180 plus 180? 360. What is 360 plus 180? 540. Okay, so that is how this is becoming 540. And now, what is A plus B plus C? That A plus B plus C is also 180. So this 180 will go to the right side. And when it goes to the right side, it will become 540 minus 180. Understood? So 540 minus 180 is again how much? 360 degree. Clear? Is that okay? Now it is fine? Is it fine, Abraham? Now, did you understand this one? Okay, fine. So all of you, please write down this and please tell me once you finish writing, please tell me in the chat box whether you finished or not. Yes. Yes, yes, yes. Please make it fast. Those of you have finished that this page. Yeah. So I'm just erasing everything here on this page. Okay. So till now we discussed about triangles. Now, if I take a quadrilateral, ABCD, same like a triangle ABCD, what are the interior angles? Angle A, angle B, angle C, angle D. So angle A plus, angle B plus, angle C plus, angle D. How much? This is a quadrilateral. In a quadrilateral, what is the sum of all angles? You know that. What is the sum of all angles in a quadrilateral? Inside it is 360 degree. Okay. This is interior angles. This is which angle? Interior angles. Okay. So when you have interior angles, these sum is 360 degree. Now, if I extend these sides, this one, this one, this one, and this one, what is the angle here? Exterior angle. This one exterior, this one exterior, this one also exterior. Can I name this? Yes, angle 1, angle 2, angle 3, and angle 4. Yeah, okay, understood everyone? Yes. So in this, what is angle A plus angle 4? What will be angle A plus angle 4? This one plus this one. Angle A plus angle 4 is that 180 degree. Is this in a line? Look at this. Is these two angles inside a single line? Yes. So that will be 180. Angle B plus angle C. What will be angle B plus angle C? Angle B plus angle C will also, not C, angle 1. Okay. So angle B plus angle 1 is also 180 degree. Angle C plus angle 2. Angle C plus angle 2 also 180 degree. Angle 3 plus angle D. Angle D plus angle 3 is also 180 degree. Okay. Same like the previous one. Can I add all this? Yes. So what will I have here? Will I have angle A plus, angle B plus, angle C plus, angle D? Yes. And on the next part, will I have angle 1 plus, angle 2 plus, angle 3 plus, angle 4? Yes. So now I have 180 plus 180 plus 180 plus 180. What is 180 plus 180 plus 180 plus 180? Yes, Abraham said that answer. 180 plus 180 plus 180 plus 180 is 720 degree. So this will be total 720 degree. Now, what is angle A plus angle B plus angle C plus angle D? 360 degree. So just put that here. So you'll be getting 360 plus angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to 720. So what will be angle 1 plus angle 2 plus angle 3 plus angle 4? That will be 720 minus 360, which is 360 degree, which will be again 360 degree. So that means exterior angle sum. Okay, exterior angle sum of quadrilateral. Exterior angle sum of quadrilateral is also how much? 360 degree. That will also become 360 degree. Clear? Not only for triangle, this is also true for a quadrilateral. This is also true for a quadrilateral. And not only for a quadrilateral, if I take a pentagon, if I take a 5-sided polygon, pentagon, if I take hexagon, if I take 10 sides, decagon. So in all this, the sum of exterior angles will be how much? 360 degrees. So this is a universal rule. Okay, for any polygon, the sum of exterior angles will always be how much? 360 degree. Clear, everyone? Please write down this. Draw this figure. Okay, draw this figure. Mark the important points and then understand it. Okay. Any doubts? Anybody? Please put that in the chat. If anyone is having doubt, please put that in the chat box. Just give me a second, everyone. Yeah. So can everyone see the screen? Now can everyone see the screen? Can you hear me? Can you all hear me? Is my voice clear? Is my sound clear? Yes. Okay. I had to switch the networks. The network is a little bad here. Yeah. So did everyone write down this? Did everyone finish this? Please tell me if you have finished. Yes. 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 Okay. So for any polygon, what is the sum of three exterior angles? It will be 360 degree. It will be 360 degree. Clear? Okay. Abraham, yeah, please finish it. Everyone, please write it down. I'll give you all 1 more minute. You can finish it fast. Please finish it, please. And during that time, if those who have finished writing this one, if there is any doubt, you can ask that in the chat box. Okay. If you guys have any doubt, you can put that in the chat box also. Yeah, I'll just call out some names. Yeah, Adrij Kumar. Hi, Adrij. Can you hear me? Akshad and Aromal. Yeah, Aromal, Flora. So these are, I think, some new names. Sejal, yes. So I think these are some of the new attendees, I guess. Yes. Please write down this fast. Yes. Okay. So moving on to the next one, we have a question: how many sides does a regular polygon have if each of its interior angles is equal to how much? 165 degree. So it is given that an interior angle. Okay, I'm not drawing the polygon. I'm just drawing an angle. So interior angle is how much? 165 degree. So if interior angle is 165 degree, what will be the exterior angle? What will be the exterior angle? Will it be 180 minus 165? Yes. So write down that. Okay, interior angle. What is the interior angle here? 165 degree. So what will be the exterior angle? What will be the outside angle? The outside angle will be 180 minus 165. That will be 15 degree. Okay, so the exterior angle we got 15 degree. Now, what is the total exterior angles? We know that the total sum of exterior angles of a polygon. We know that total sum of exterior angles for any polygon. Okay, not only for which one? Triangle or quadrilateral. For any polygon, the total sum of exterior angles will be 360 degree. So if we have total sum of exterior angles 360, one exterior angle 15 degree, what is the number of sides? How can you calculate the number of sides? The number of sides can be calculated using the formula 360 divided by interior angle. 360 divided by interior angle. Okay, so you learn this formula, you can do any question. Okay, so number of sides will be equal to 360 divided by an interior angle. So that will be 360 divided by 24. So what will be I wrote the answer there. Sorry. So what will be 360 divided by 15? So what will be 360 divided by 15? It will be 24 sides. Is that clear? Is this part clear to everyone? Yes. So what will be the number of sides for a polygon? Here it will be 24 sides. So number of sides can be calculated using the formula 360 divided by exterior angle. Interior angle. Oh, did I write interior angle? Sorry. Why the eraser is not coming? Yeah, this is not 360 divided by interior angle. This is 360 divided by the exterior angle. Okay, I have written that formula wrong. So 360 divided by exterior angle, that will be 24 sides. Is this clear to everyone? Yes. Can we move on to the next one? Finished? All of you finished? Any doubts, anybody? Is anyone having any doubt in this? Please ask, please ask. Anybody is having any doubts? Okay, fine. So next, moving on to the different types of quadrilaterals. There are different types of quadrilaterals that we have throughout, right? So you might have studied about trapezium, kite, and parallelograms. So we will look one by one. So what are the different types? We have trapeziums, we have kite, and then we have parallelograms. What is a trapezium? Okay, so what is a trapezium? So let's look at what is a trapezium. So a trapezium is nothing but a four-sided figure, closed figure. Sometimes this closed figure is very important. So a four-sided closed figure with two sides parallel to each other. Okay, two sides will be parallel, not the four sides. Okay, so two sides will be parallel to each other, and such a one is called as what? Trapezium. So if I draw something like this, I don't know whether it will be correct. Yeah. So if I draw something like this, A, B, C, D, if I mark it as A, B, C, D, is AB parallel to CD here? Yes. So AB is parallel to CD. So AB is parallel to CD. Is BC parallel to AD? No. BC is not parallel to what? AD. So here only one pair is parallel. Which pair is parallel? AB is parallel to CD. And the next pair, the second pair is not parallel. So if in such cases where only one pair is parallel to each other, that quadrilateral can be definitely called by the name a trapezium. That quadrilateral can be called by the name a trapezium. Clear? Understood, everyone? Yes. So this is a trapezium. This ABCD out here is a trapezium. Now, in this trapezium, if I am taking AD equal to BC. In this trapezium, if I'm taking AD equal to BC, okay. Can you say that AD is equal to BC? Yes. So in this trapezium, if AD equal to BC, such trapeziums are called by the name isosceles trapezium. Such trapeziums can be called by the name isosceles trapezium. Clear? So what is an isosceles trapezium? It is a trapezium only. What is the speciality? Two sides will be equal. What are the two sides? The non-parallel sides. AB and BC, AB and CD are what sides? AB and CD are parallel sides. BC and AD are what sides? Non-parallel sides. BC and AD are non-parallel sides. So if the non-parallel sides BC is equal to AD, then we can call it by the name an isosceles trapezium. An isosceles trapezium. Okay. And one more thing I want to tell you here. I don't think you have that to study this year. What is the area of trapezium? What is the area of trapezium? Okay, I'll just teach you here. Area of a trapezium is found out by finding the height. What is the height? This is the height of a trapezium. So this is the height of a trapezium. So if this is the height of a trapezium, you can easily find out the area. You can easily find out the area. How? Half into height. Okay, half into height into sum of parallel sides. So half into height into sum of parallel sides. So that will be half into, what is the height here? H, into, what is the parallel sides? One is AB and the other one is CD. So you have to write as AB plus CD. Understood? So using this formula, we can find out area. Okay. This you will learn in another chapter. This you will learn definitely in some other chapter. I think you have a chapter named as mensuration. I think so. You have a chapter number 10 or 11 or something. Yeah. So in that chapter, you will be definitely learning this one. For the time being, just understand this. Area of a trapezium can be calculated by the formula half into height into AB plus CD. Okay. Please write it down, everyone. Please write it down fast. Please make it fast. Yes, so this is the trapezium. Okay, so everyone finished? Yeah, can we go to the next one? What is the next one? Kite. You might have all tried to make a kite at least once, right? When you might have gone to visit a beach, or when you might have gone like in a terrace during, I think Dasara, not during Dasara, but maybe I think during some festival. Some festival they usually fly this kite. So I have also tried many times and it was never successful. What happens is my kite will always be down, going down. It won't be going up. Okay. And this has happened many times, multiple times. And whenever we go to some beaches, we can see that people are flying the kites like they're flying some kind of rockets. So that much expert people are there, right? Those who are flying kites. So there are people who can make kite in a good way. I think maybe in this class also, maybe in the attendees also, maybe somebody might have made a kite successfully. Is there anyone? Is there anyone who has made a kite successfully? Akshad, yeah, Akshad and me are in the same page. Adit, yeah, Adit has made with newspaper. Very good, very good. Were you able to fly that kite properly? I have tried in my childhood to fly a kite, not the normal way, but there was no wind actually. So what I did was I tied my kite with my bicycle, and then I was riding my bicycle and thought that it will fly. Then also did not fly. Okay, so multiple failure attempts were from my side. Yeah. So main thing I observed is not because of the shape; it's maybe because of the weight. Maybe when we put more paper, when we put a bigger newspaper, or maybe when we put glue and all these things, this will have more weight. I think maybe because of that only that time also did not fly. Okay, everyone, when you are making a kite again, please check with, please do it with a lighter paper. Some oil papers are there, right? Yeah, oil papers or something like that. So try to make with those kinds of papers. I think maybe it might fly. One made of plastic bag and it flies high. One bit. Yeah, plastic bag. Okay, fine. Okay, I agree. Plastic will definitely fly in high windy day or low wind also. I think it should fly. Okay. Anyway, what is the shape of this kite? You might have when you guys made a kite, you might have observed that the kite looks like this, right? So the kite, we always try to make the kite which is looking like this, and it is always very hard to make a paper folding in this way. So what is the speciality of this shape? So this shape is definitely what we call as a kite, and the speciality is if I mark this as A, B, C, D, if I mark it as A, B, C, D, the adjacent sides are equal. What are equal? The adjacent sides. So here AB should be equal to AD. Here AB should be equal to AD. And also BC should be equal to what? BC should be equal to CD. So these two pairs of adjacent sides, should be equal. So only if they're equal, then we can call it as a kite. Only when they're equal, we can call it as a kite. Okay. And also understand when we connect these two, you're having a line, right? So I think that line is not proper. Yeah. So I'll just draw a line here, and there is another line which connects these two. So these are diagonals. So AC is a diagonal, BD is also diagonal. Yes, they are diagonals. Now, what is the specialty of these two diagonals? These two diagonals will meet at what angle? 90 degree. What is the angle in which they meet? They will meet at 90 degree. Okay. So what I used to do when I was making a kite is I used to take two what do you call it? Two sticks, one smaller stick BD and another longer stick, which one? AC. So I used to take these two sticks and I join them first and then put a paper on top. I then wrap it using a paper. So that was what I tried. Okay. I don't know how others tried. So this was the method that I did, and this was the shape also. So you could see that this shape, if I take a this one twine, or if I take a small rope or something, and if I connect it with that, I'll be definitely getting a kite which may fly or which may not fly. Okay, flying or something, we will keep it to the next class. So this shape is nothing but a kite. So what is the specialty of a kite? The adjacent sides are equal. So in a kite, definitely the adjacent sides will be equal. Okay, and the which one? The diagonals BD and AC will be perpendicular. These two diagonals will be perpendicular. So this is a speciality of the next type of quadrilateral. What is a quadrilateral called as? It is a kite, and this kite is having this kind of speciality, that is adjacent sides will be equal and the diagonals will be perpendicular to each other. Okay, can everyone write down this fast? Please make it fast. Okay, done. So can we move on to the next one? The very important, the most important one, that is a parallelogram. Okay, the parallelogram. So what is a parallelogram? So a parallelogram is nothing but a quadrilateral with both the pairs parallel to each other. So for example, if I take AB and CD, AB and CD will be parallel to each other. AB and CD will be parallel to each other. So this AB and this CD will be parallel. Same like that, BC and AD also will be parallel. Understood? So AB and CD are parallel. BC and AD are also parallel. Understood? Clear? Yes. So this is a specialty of a parallelogram. So this is also a type of a quadrilateral where opposite sides are parallel. So what is the specialty of a parallelogram? The opposite sides are definitely going to be parallel. The opposite sides are parallel. Now, not only sides are parallel, what about the angles? This angle B will be equal to angle D. Okay, so that means opposite angles are also equal. So in a parallelogram, opposite angles are also equal. So angle B will be equal to angle D. And look at this angle, angle C and angle A. Angle C will be equal to angle A. So angle B will be equal to angle D, angle C will be equal to angle A. Opposite angles are equal. Now, not only opposite angles, what else is equal? Opposite sides also are equal. Opposite sides are equal. Opposite sides are equal. So what is the side AB? What is opposite CD? So AB is equal to CD. AB will be equal to what? CD. Understood? Clear? Yes. So AB will be equal to CD, and also look at this side opposite BC. Yes, BC is equal to AD. Understood? So AB will be equal to CD and BC will be equal to AD. So this is the second one, that is opposite sides are equal, opposite sides are parallel, opposite angles are also equal. Now, what about the adjacent angles? What about adjacent angles? When you have two angles like this, angle A and angle B, can you see that angle A plus angle B will be equal to 180 degree? Yes. So adjacent angles are not equal here. Adjacent angles are supplementary. Adjacent angles are what? Supplementary. Adjacent angles are supplementary. Angle A plus angle B will be 180 degree. Same like this, angle C plus angle D. Angle C plus angle D will also be 180 degree. Angle A plus angle D. Angle A plus angle D will also be 180 degree. Angle B plus angle C. Angle B plus angle C will also be 180 degree. Clear? So understood? So understood this one, everyone? So adjacent angles are not equal. Adjacent angles are going to be supplementary. They will be you will be having a sum of how much? 180 degree when you take that. Clear? Okay, understood everyone? So I hope everyone understood this particular topic. Does parallelogram have diagonals? Yes, Srinidhi, parallelogram has diagonals. I'm going to that. Okay, once you guys finish this one, I will go to the diagonals of a parallelogram. Okay, so please finish this one. Now, as Srinidhi told, when you join A and C, you are getting this one, AC. And when you join B and D, you will be getting which one? BD. So this AC and BD are what? AC and BD are diagonals. AC and BD are diagonals. Now, in a parallelogram, there is a speciality. What is the speciality? The diagonals bisect each other. The diagonals bisect each other. Clear? So this is a speciality of a parallelogram. So in a parallelogram, the diagonals are not equal. The diagonals are not equal, but the diagonals will definitely bisect each other. Diagonals will definitely bisect each other. And what is mean by bisecting? Suppose these two diagonals meet at the point O. Okay, let them meet at point O. Then AO will be equal to what? AO will be equal to CO. That is what we call bisecting. Same like that. BO will be equal to what? DO. BO will be equal to DO. So AO will be equal to CO and BO will be equal to DO. This is what the speciality of the diagonal. So diagonals will be bisecting each other in a parallelogram. Understood everyone? That is very important property. Diagonals will bisect in a parallelogram. Okay. Now, when you have a parallelogram like this, what is the area of a parallelogram? How can you tell about the area of a parallelogram? This is called as a base, and this distance can be called as what? The height. This distance is the height. So this area will be what? Base into height. Clear? So this area will be what? Base into height. So for a parallelogram, the area will be nothing but the base into height. Clear? Understood everyone? All of you understood? Please put a message in the chat box. Please don't drop your energy. Please don't drop your energy. Please put a message if you have understood or not. If you are having any doubts, please put that in the message. Yes, yes, very good, very good. Yeah. So can we move on to this one? Everyone understood this parallelogram thing? Is there any doubts in parallelogram? I hope nobody's having any doubts in parallelogram, right? Yes. So now we have special types of parallelograms also. Okay. And in that we have rhombus, we have square, and we have rectangle. A rhombus, square, and rectangle. Let us look at each one by one. Okay. So what is the first one? We have rhombus. So rhombus is nothing but all sides are equal. So rhombus will be a parallelogram where all sides are equal. Okay. So if you have a parallelogram, if you have something like this, A, B, C, D. So here what all are equal? AB is equal to BC is equal to CD equal to AD. So all four sides are equal. Yes. So if all four sides are equal, but angles, are they equal? Angles are not equal. Okay. Angles are not equal. So only sides are equal. So if only all sides are equal, then we can call it by the name rhombus. Okay. Then we can call it by the name rhombus. And what is the speciality of the diagonals? If I join this one and if I join this one, the diagonals AC and BD are bisecting what? They will bisect perpendicularly. They will bisect perpendicularly. That is, they will bisect at what angle over here? 90 degree. They will make an angle 90 degree. Understood? Understood this one, everyone? Yes. So in a rhombus, the diagonals bisect, or the diagonals are perpendicular bisectors of each other. The diagonals are perpendicular bisectors of each other. Clear? Understood? So this is a speciality of a rhombus. Now, if somebody is asking you the area of a rhombus, what is the area of a rhombus? To find out the area of a rhombus, what I can do is I have to first draw the diagonals again. Okay, I'm just drawing the diagonals. So when I draw the diagonals, there's a diagonal here. Yes, I'm marking it as D1, diagonal D1, and this diagonal as D2. So if I have the diagonal D1 and D2, I can easily find out the area using half into D1 into D2. So what is the area of a rhombus? It is half into D1 into D2. Is this clear? Everyone understood? So half into D1 into D2 will be the area of a rhombus. So this is about a rhombus. Now, when we talk about the next one, who's the next one? Square. What is the specialty of a square? In square, not all sides are equal. Yes, all sides are equal. Yes. So square, all sides are equal. But what about the angles? All angles are also equal. How much? 90 degrees. So when I draw a square like this, yeah, so this is a square. A, B, C, D is a square. So here, what are equal? AB is equal to BC is equal to CD equal to AD, and also angle A equal to angle B equal to angle C equal to angle D is how much? 90 degree. Okay, so all these are going to be equal to each other. Now, about the diagonals AC and which one? BD. The diagonals are also equal. AC and BD are also equal. So always remember, in a square, okay, in a rhombus, diagonals are not equal. Here in this one, diagonals are not equal. But here in this square, what is equal? The diagonals are definitely going to be equal. So AC is going to be equal to BD. So if AC is going to be equal to BD, and this diagonals will also meet perpendicularly. That is, AC will be perpendicular to what? BD. AC will be perpendicular to BD. So this is in a square. Now, when we talk about the rectangle, what is a rectangle? A rectangle is a four-sided figure where opposite sides are equal. So here AB is equal to CD and AD equal to BC. And what about the angles? The angles here, all angles are how much? 90 degree. Angle A equal to angle B equal to angle C equal to angle D. How much? 90 degree. Now, what about the diagonals? The diagonals are going to be equal. So in a rectangle, the diagonals AC will be equal to BD. Diagonals will be equal. But these diagonals, are they meeting at 90 degree? No. So diagonals does not intersect, or diagonals does not bisect at how much? They does not bisect at 90 degrees. So here in a rectangle, the diagonals does not bisect at 90 degree, but in a square and in a rhombus, in a square and a rhombus, the diagonals are bisecting each other. Clear? Understood? All of you? So these are the different types of parallelograms. Can you guys write it down? Can everyone please write it down? All of you please write it down. Please make it fast. So is anybody having any doubt in this one? Types of parallelogram? No, I guess nobody's having any doubt. So can we move to the next one? Yes. So name the quadrilaterals whose diagonals bisect each other. So which are the quadrilaterals whose diagonals bisect each other? We know that the diagonals bisect each other in which one? A rhombus. Does it bisect in a rhombus? Yes. In a square, does it bisect? Yes. So rhombus and square, the diagonals bisect each other. Okay. Only in rhombus and square does it bisect each other? No. It is also bisecting bisecting in which one? In a parallelogram also. So in a parallelogram also, is it bisecting? Yes. In a rectangle, it does not bisect. Okay. Sorry. In a rectangle also, it bisects. Yeah. Rectangle also it bisects. Okay. So in rhombus, square, parallelogram, rectangle, in all these cases, we can say that the diagonals will bisect each other. In trapezium, it is not bisecting. Okay. In trapezium, it will not bisect each other. Now, in which all quadrilaterals are the perpendicular bisectors of each other? Which are quadrilaterals are the perpendicular bisectors? They are perpendicular bisectors in square and a rhombus only. Square and rhombus only. Understood? In kite, it is not, it is perpendicular. Bhavya, kite, it is perpendicular. Okay. In kite, it is perpendicular. The diagonals are perpendicular, but not bisectors. Bisectors means this one should be equal to this one. Are they going to be equal? No. And below the kite, it is greater, it is longer, and upper and on top of the kite, it is shorter. So that means they are not going to bisect. They will be perpendicular, but they will not be bisecting. Okay. Now, what are the quadrilaterals whose diagonals are equal? Which all quadrilaterals would have diagonals which are equal? We have diagonals equal in square, yes, and also in which one? Rectangles. So in square and rectangle, what will be equal? The diagonals will be equal. Clear? Understood, everyone? Yes. So there is a question: the adjacent figure hope is a parallelogram. You need to find out the measure of x, y, and z. Okay. So look at this one. Can you see that this? We know that this side is parallel to this side. Yes. So this angle, the whole angle over here should be equal to which one? The whole angle over here should be equal to 70 degree. Can we find out 70 degree using that? No, we cannot find. Okay. So can you see this one, this y and this angle? Are these two sides parallel? Is OP parallel to HE? Is this OP parallel to HE? Yes. So if OP is parallel to HE, can we write this angle y is equal to which one? 40 degree. So can we write angle y is equal to 40 degree? Yes. I can write angle y is equal to 40 degree. Is that clear? Yes. So this angle y, we got 40 degree. Now look this one. Is this angle 40? This 40 plus z is going to be equal to 70 because corresponding angles. This one here, what happens? Alternate interior angles. This is alternate interior angle. Now here the next one. What is the angle here? 40 plus z. What is this 40 plus z is equal to? That will be equal to 70 degree. What is the reason? Corresponding angles. They are corresponding. Okay. So if 40 plus z is equal to 70, what is z from this? That is going to be 70 minus 40. How much? 30 degree. So what is the angle here? It will be 30 degree. Clear? Yes. Now you need to find out this one, x. If this is 70 degree, what is this angle? What is this interior angle? Can we write that interior angle as 180 minus 70? Yes. So angle HOP, can I write it as 180 minus 70? Yes. How much is that? 110 degree. So this angle over here is 110 degree. We have studied that in parallelogram opposite angles are equal. Yes. So is angle X equal to angle HOP? Yes. What is the reason? Opposite angles are equal. So if opposite angles are equal, can we write X is equal to 110 degree? Yes. So X is also equal to 110 degree. So X is 110 degree, Y is 40 degree, Z is equal to 30 degree. Clear? Understood, everyone? Yes. So can we move on to the next one? Find the value of X and Y in each of the following figure where ABCD is a parallelogram. So in parallelogram, I told you the diagonals bisect each other. So if I am writing this point as O, is this 3x minus 1 going to be equal to 2 into x plus 1? Yes. So can I write 3x minus 1 is equal to 2 into x plus 1? Yes. So what is that 3x minus 1? What is 2 into x plus 1? 2x plus 2. 2x plus 2. Taking this 2x, we will be getting 3x minus 2x. Minus 1, you will be getting 2 plus 1. So this is x. This is what? 3. So what is the value of x? Is 3. So did we get the value of x? Yes. Now, like this, can you find out the value of this one also? So here in the first case, what was equal? BO is equal to DO. BO is equal to DO. Okay. Now, in the second one, what we have to take? CO is equal to AO. CO is equal to AO. So we can write 6y minus 1 is equal to 5y plus 1. Taking this 5y, we will get 6y minus 5y. 1, we will be getting 1 plus 1. So this will be y, and 1 plus 1 is equal to 2. So what is the value of y? It will be 2. So x value will be 3, y value will be 2. Understood? All of you? So what is the property that we have used here? The diagonals of a parallelogram. The diagonals of a parallelogram bisect each other. The diagonals of a parallelogram will bisect each other. Clear? Understood, everyone? Yes. So thank you everyone for this joining the session. Everyone, I think almost the last class, how many people we had, that same number was there today also. So thank you everyone for joining the session. I think you might have another class at 7 o'clock. I think maybe, no, I don't know. So thank you for joining the session, everyone. And tomorrow also we'll be having another one at 6 o'clock where we'll be studying data handling. Okay, so you have to join that and study data handling. What is the graph? How will you draw the graph and all these things? We will be studying tomorrow. So make sure everyone join tomorrow with the same energy that you had in the last 3 classes. Okay, as I told you, don't drop your energy. Please make sure that you have the same energy till the end of tomorrow. Okay, tomorrow will be our last session. And tomorrow we will be looking at data handling. Okay, tell your friends also to join the class because this is the last class. Please tell everyone to join. Okay, make sure that the number is very high. Tomorrow, many number of people should come and join the session. Okay, thank you everyone. Thank you once again. Bye. Okay, study well, study well, everyone. Have a nice day. Yeah, thank you.